My goodness. Hello, everyone. It's so amazing to be here with you in London. This is the second time I've been to this beautiful town, and I absolutely love it every time I come. So I'm Duffie Cooley. I'm the field CTO at IOvisor. We were recently acquired by Cisco, and we're doing all the same things that we were doing before that acquisition. We're still going to business the same way. Nothing's really changed. If you want to talk to me about Cilium or Tetron or any of those things, I'm here all day today and tomorrow, and also UBF or pretty much anything else. I love to talk about all kinds of stuff. So my job hasn't changed too much. Come say hello. Like Cheryl, I definitely invite you to go and meet everyone while you're here. To that end, the first part of this talk is going to be about perspective. In philosophy, a perspective is a specific way or manner through which a person thinks about something or approaches a problem, or in the figurative use of this has been around since like 1730. It's often described as the context for opinions or beliefs or experiences. And it's a fascinating topic. When you're troubleshooting or converting an idea to code or thinking about a hard problem, your perspective is the tool that you use, and it's one that you should strengthen. Like any tool, we actually can strengthen our perspective through shared experiences, by telling each other's challenges, challenges that we've overcome, and all of those things. Because every little piece of that really helps widen our own perspective, gives us a better set of tools with which to approach a problem. For me, one of the best ways to improve my perspective is teaching, sharing ideas, hearing questions. Like, I can only ever understand a problem with my own eyes and my own hands unless I'm explaining that problem to someone else. And they ask me questions that show me a face of that problem that I would otherwise have never seen. And here in this moment, here at this event, is an incredible opportunity to widen your perspective and to really put intent into that. At any of these things, anywhere there's a hallway track, you're going to have the ability to really grow that perspective, grow that tool set that you have. How many of you have heard of rubber duck debugging? This is a thing that, every time I mention it to somebody who is familiar with it, they're like, this completely unlocked my career. Like, it completely made a change. And the fascinating thing about it is, rubber duck debugging is the idea that you're going to use your voice and talk about some particular problem that you have, some particular hard compute problem, could be any number of different things. But just the process of converting the problem that you have in your mind to words forces you into a different perspective. Again, widening that perspective, again, changing everything about it. And inevitably, I don't know, for me anyway, whenever I start explaining a problem, the solution pops right up. It's amazing. So on to how all of this applies to security. Here is another perspective. This was posted right after Andres happened upon something that just didn't seem right. It was bugging him. He was curious about it. In his experience, SSH shouldn't be using so much CPU time as part of its testing. So he was curious about why this behavior was happening. Are we all familiar with what's happening here? This is the SSH libLZMA or XZ CVE that came out, right? Where there was a lot of really interesting stuff that kind of lined up around this. So Andre has some experience with profiling tools and while benchmarking some Postgres changes, noticed that OpenSSH performance wasn't as expected. And he dug a little deeper and found one of the most interesting and sophisticated software vulnerabilities of our time, in my opinion. Like, it really, up until this moment, if you had described somebody going through all of the work to do this type of exploit or this type of vulnerability, somebody would have looked at you like you were crazy. It would not have been possible that somebody would do this. But literally years, right? Someone had spent years moving into a maintainer position with a libLZMA library, committed code, made changes to the security of that software so that they could produce an exploit that would work with OpenSSH. It's amazing. Like, it's absolutely amazing. And if you're curious more, if you want to read more about it, I highly recommend this XZ timeline that was written by Russ Cox. It really gives you a good view of how all of this works. But it's a very sophisticated and amazing change in the way that we think about these things. One of the great things about this, however, was that, unlike many of us probably on a day-to-day basis, Andres was curious. He's like, this doesn't seem right. He dug deeper. He embraced that curiosity. Even though he's on a timeline, he's got to get his job done. He's got to keep going. He's on a deadline just like all of us. But he didn't let that stop him from being curious. He dug in deeper, right? How did that happen? How often do you, in your day-to-day work, think, why, that's something weird, like how did that happen? And then just quickly mash the retest button when looking at CI results. I know we all have things to do and we all feel the pressure of time. And when you thought, I wonder if, or how did that happen, that was an opportunity to be curious, to dig deeper, to think about the problem differently than you did. Each of these opportunities represent a way to improve our perspective, the actual quality of our work. And sometimes we can find things that we did not think that were even possible, like this work here. So how can we experiment with this? Obviously talking to each other, sharing our perspectives, that widens our perspective. But what are some tools that we can use to kind of actually widen our perspective about the software that we use, the infrastructure that we use, the things that we actually interact with? So for me, in the last few years, it's been eBPF. This is an incredible technology. It has the ability to gather context at pretty much any layer of the stack, whether it's where your application is spending CPU time, whether it's what's happening on the network, whether it's just understanding all of the different things that are happening on the server underneath all of the applications that we deploy. There's just a ton of capability in eBPF. Before containers, we had a tool called audit-D, and audit-D had a much simpler life because there was just the one PID namespace, there was just the one network interface, maybe connected to a server. All of the applications were running there in the host PID namespace. All of those things happened. We introduced containers, and audit-D quickly lost context because now we have different networks, different network namespaces, different PID namespaces, different file systems associated with individual processes that we now call containers. I think this is where eBPF really shines. With functionality from eBPF helpers and frameworks like that, we get all of that context back. It's also a thriving ecosystem of tooling. And with that tooling, we can answer questions like, is my problem DNS? Is my problem, where is my application spending all of its CPU time? What can I do to improve the performance of these things? At the end of the day, you can't improve what you can't measure. And this is where I think a lot of the tooling that I see out there in the ecosystem really comes in. This is actually a graphic from one of the tools, IOvisor BCC. This is actually one of the first ones that I ever discovered that introduced me to the idea of eBPF. A lot of this was kind of brought up with the work that Brendan Gregg did when he was first kind of getting involved in eBPF. If you have watched the eBPF documentary, you'll understand that getting eBPF merged into the Linux kernel as a technology, just getting it to the place where it is today has been a very interesting and colorful journey. But the second use case for eBPF was actually observability, monitoring, understanding what was actually happening on a Linux kernel that you perhaps didn't compile on your own. So how can you go about profiling applications and those sorts of things? And that is where a lot of these things come in. But even just from the scope of what's happening inside of this graph, you can see that just these each of these things on the outside edges are the tools that already exist within this library that you can use today to understand the performance of your application as it relates to any of these contexts, right, in the BCC toolkit. Other projects that are using eBPF, right? BPF Trace, Inspector Gadget, these are tools that also make it easier to apply things like the BCC toolset against your applications deployed inside of Kubernetes. There are things like Tracy, which are meant to capture enough information for forensic analysis for applications that are doing interesting things and being able to kind of check on those things. Parka and Pixie are tools, again, that look, Parka is a tool that does continuous profiling. So that question of why is my application doing weird things, or where is my application best optimized for things that are happening? Continuous profiling is great for that. And Pixie is again, another tool that kind of digs into sort of automatic instrumentation for applications at that layer. We also have Cilium and Tetragon, the kind of stuff that I work on. Tetron is a tool that gathers context from the Linux kernel. It's not a networking tool per se. It's actually an entire thing to do with the Linux kernel. Anything inside the Linux kernel is something that you can inspect with Tetron. Tetron emits by default a bunch of event data about what is actually happening or executing inside of the Linux kernel. What are the other processes doing in this big shared Linux kernel that we have that is running a kubelet? So an example of some of the output that we see, I mean, just to kind of giving you a view of sort of like how you can widen your perspective about what's actually happening at a lower layer, like below the application, right? So in this example, what I'm showing is just the output of Tetra's CLI in a kind of an abbreviated format. Behind every one of these events, there's a ton more information, like what node it happened on, like what kind of capabilities that particular process had, what the permissions are what the effective permission set of that process was, a ton of other data in there. And this is just the default configuration. There's a lot more that you can do to turn up the amount of information or to tune the amount of information that you get. If you want to see DNS requests and DNS replies, if you want to see all of those things are available to you within Tetron. In this example, we're seeing kubeproxy programming IP tables to configure a service. We also see Kindnet, because I'm actually using a Kind cluster in this particular example. So lots of interesting stuff there. And this is, again, just the tip of the iceberg. Do you remember the XZ example that we were just talking about moments ago? So this is an example of a tracing policy that would allow you to actually see if, when SSH starts up, and this happens every time somebody SSHs into a server, whenever that process is loaded into memory, we would be able to see the libraries that process loads. So from that perspective, we can even just kind of express that, hey, you're actually loading a vulnerable version of this of the liblzma, and we can emit an event, we can take action. There's a ton of capability there. So as I said before, like these tools and all of the things that I've mentioned before are just ways to kind of like widen your perspective about what's happening on the node where you're deploying your application. Widen your perspective about the application itself. But nothing widens your perspective as a human, as an engineer, as a person, more than hanging out with this crew, hanging out with these people, and experiencing that hallway track, talking to each other, meeting each other, talking about the challenges that everybody had. Some of the smartest people that I know and have ever worked with absolutely take advantage of that every single time. You'll see us talking about the hallway track. Be sure to be a part of it. This is my resources slide. All of these things are available to you. If you want to actually get more involved in like actually being a part of the community and actually showing up and like being a part of something even more amazing than all of this, I highly recommend these last two links, github.com/CNCF tags. These are technical advisory groups to the CNCF. And those tags are focused on a variety of different things, from security to networking to just a ton of different verticals within our space. And they all need help. They all need people to come and be a part of it to help us grow it into something that's even more amazing. And that last link, kubernetes.dev, you're all here because you're familiar with Kubernetes, but maybe you want to be a little more involved in making the sausage, like in actually being a part of the project. Kubernetes.dev is a great way in. Kubernetes.dev gives you a list of all of the different special interest groups that Kubernetes is a part of, and it gives you links to calendars where you can actually just go start showing up to those meetings and getting involved, taking issues, helping actually move all of those things forward so that all of us can appreciate them even more. So you're welcome, and I'm more than happy to welcome you to this community and to everything else about it. I'll be here for the next 2 days doing all of this. And my last point is that the important thing is not to stop questioning. Curiosity has its own reason for existence. And you should all stay curious. So thank you all so much.